everyone. As you've heard, my name is Hassan Jurde, and today my talk is going to be Understanding Client-Side Routing with Vue.js. Before I begin, I'll give you all a brief introduction of myself. I graduated as an engineer from the University of Toronto in Canada in 2015. Right after graduating, I joined a digital agency of a consulting group called Deloitte Digital, and this is where I started to help clients build and scale their front-end applications. And today, I'm a front-end developer for the commerce company known as Shopify. And I've just recently finished a project known as Full Stack Vue, the complete guide to Vue.js. So now with that out of the way, before I talk about routing or client-side routing, I'll give you all a very brief introduction to what Vue is for those who may be unaware. So from the main website, it says that Vue is the progressive JavaScript framework that is approachable, versatile, and performant. Now, what does that actually mean? We'll break it down. Vue is recognized to be progressive because it scales up as easy as it scales down. For very simple use cases, you can use Vue like you use jQuery, by dropping a single script tag. But as your needs start to grow, Vue grows with you to make you more powerful and more productive. It's also recognized to be approachable, because as long as you know standard HTML, CSS, and JavaScript, you can get started working with Vue right away to building your web applications. It's performant, since it takes advantage of the virtual DOM for very fast re-rendering times. And finally, it's versatile, because Vue is a library that fits within an ecosystem of tools, like Vuex for state management, Vue Router for routing, and the Vue Test Utils as the official testing library. So there's a lot of things we can talk about, but today we're going to focus on one particular topic, and that is routing. Now, there's many ways to explain what routing is, but one way we consider routing is that routing often refers to splitting an application's UI based on rules derived from the browser URL. Now, we've all seen examples of this. Like, we can go to our favorite websites. Let's say twitter.com as an example. In the index route, and as a logged-in user, you expect to see this screen. You expect to see the feed of your followers posting information, the potential followers you can follow, some details on your profile, etc. But if I click, let's say, the link on my name on the top left corner, I'm directed to my profile page. But why is my profile page being shown at this very moment? That's dictated by the browser URL. I'm not in the index route anymore. I'm in a route that says twitter.com/jurdeh. Jurdeh is my username. So we can say that this is a dynamic route, in which the dynamic part of the actual route is the username. This dynamic route is responsible in displaying the profile page of the user. So in essence, a URL is basically an identifier to a resource on the internet. But if you go into more detail, a URL can be broken down to three parts: the protocol identifier, the host name, or in other words, the domain name, and the path name. The protocol identifier and the host name combined help direct us to a certain website. HTTPS www.twitter.com takes us to the Twitter application. The path name portion is an indicator to a particular resource on that website. So when you say twitter.com, somebody's username, we want to go to the profile page of that user. And like I said, we're all familiar with this, but this gives us a significant amount of advantages. We're now able to refresh pages and keep our location in the app. We're able to bookmark URLs and even share it with others. And finally, we're able to maintain browser back-forward history functionality. So if we were going to implement routing into a web app, these are the things we want to actually make sure work. So with that being said, how do we actually go about implementing routing within a web app? There's one of two big ways, and I consider them as two big buckets: server-side routing and client-side routing. Server-side routing is when the client makes a request to the server on every single URL change. While in client-side routing, the client only makes a request to the server upon the very first initial page load. Now, each of these methods have their advantages and disadvantages. In server-side routing, apps usually have a better first paint or first meaningful paint time. First meaningful paint is the amount of time needed for the first meaningful content to be displayed to the user. Since in server-side routed applications, the client does not need to make a request to the entire application bundle, the amount of time usually needed to render some meaningful content is usually better. And in addition, in server-side routed applications, there's usually some form of content on the server before the client even retrieves it. This content can be crawled with search crawlers, which gives it a more consistent SEO performance to search engines. But in client-side routing, the main advantage is usually faster routing after the initial page load. This is because once the entire application is available, the client does not need to make multiple requests to the server. It has all the data it needs. And this also avoids or removes that blinking period we're all familiar with, which leads to smoother transitions and changes. So like I said, there's two methods. I'm not here to say one is better than the other, but today our focus is going to be on client-side routing. Applications that are client-side routed or have client-side routing are often labeled as single-page applications, or SPAs for short. In modern web applications, single-page apps are apps that load only once, and JavaScript is used to dynamically render different page content. And today, we're going to focus on building a single-page application of our own. And our application is going to be a Pokemon routing app, and its responsibility is to display details of different Pokemon based on the route that the user is in. I hope there's a lot of Pokemon fans or ex-fans. So at first, we're only going to have 3 routes, /Charizard, /Blastoise, and /Venusaur. And these routes will display details of this Pokemon. In the index route, we'll also see details of the Charizard Pokemon. But when the user actually goes to the Blastoise path name, they'll see details of the Blastoise Pokemon. In the Venusaur path name, they'll see details of the Venusaur Pokemon. And in the Charizard path name, they'll also see details of the Charizard Pokemon. Notice how the UI changes when the user goes from route to route. There's no blinking period. There's no page loading. This is because the entire application is available to the client. The client is using JavaScript to dynamically re-render page content. And by the end of the presentation, we're going to build this with the help of the Vue router library integrated into a Vue application. But before we even get to that point, we'll build it with Vue, but with our own custom client-side router. This will give us an idea of what's actually needed to integrate client-side routing. Now, as we discuss how we're going to build this, we're not going to talk about every single line of code, but instead more of the bigger pieces and how they interact with one another. We'll assume, first and foremost, that our application is a Webpack bundled Vue app. Webpack bundled Vue apps usually have a series of files and folders associated with the configuration. We won't focus on that. We'll just focus on the source folder associated with building the app. At first, we'll assume we only have an app directory that contains an app.vue file and a main.js file. The main.js file is going to be the starting point of the Vue application. It's where we import the Vue library, we import the app component, and where we declare the Vue instance. The Vue instance is the heart of a Vue application. It's where we specify the DOM element our Vue app is going to be mounted upon, as well as the uppermost parent component that's going to be rendered. Here, we're specifying a new Vue instance by saying new Vue and passing it the options it expects. We're specifying the DOM element with the ID of app is where our app is going to be mounted upon. And we're rendering a component named app as the parent and uppermost parent component of our application. We're going to spend a decent amount of time talking about Vue components, so I'm going to take a step back and explain what they are. So Vue components are basically coupled units of functionality that allow us to group markup, logic, and styles. In Vue, there's usually one of 2 ways where we can define Vue components. In standalone Vue applications, we can use the Vue.component constructor to define a component globally. The first argument, you specify the name of the component, and in the second argument, the options that the component contains. Its template, its data, its methods, etc. But in pre-compiled Vue applications, these are Vue apps that are compiled with Webpack and use the Vue loader library. We actually are able to define our components in single file format. This gives us the advantage of defining our markup in a template section, our logic in a script section, and our styles in a style section. Single file components constitute having a single file for every single component, hence the name. And these files are denoted with a .vue extension. Since our application is going to be a Webpack bundled Vue app, we'll build all our components in single file format. So now if we take a look at the parent app component that's being rendered in our app, let's assume in the template we only have markup associated with the Charizard Pokemon. I'm not showing every single line of code, but let's assume we have all the div elements, etc., that represent only the Charizard Pokemon. In the script section, we'll export the components and give it the name of app. So now, when we run the application, and now assuming our app runs on port 8080, we'll only see details of the Charizard Pokemon. This is dictated by the parent app component that's being used. Now, we can see that we're using all the information for a single Pokemon, so why don't we externalize this to a component of its own? We can call that Charizard Card, and that component can be created in a file of its own, charizardcard.vue. The template of Charizard Card will have the same markup as before, just a markup for the Charizard Pokemon, but the script will now export the component to give it the name of Charizard Card. So the parent app component will now look different. The parent app component will import Charizard Card, declare it in a components property, and render it in the template. So in the UI, nothing changes. In the UI, we still see the exact same details, but the way we've structured it is a little different. Now we have a parent app component that's rendering a Charizard Card component. Why are we doing that? This now allows us to create other component files for other Pokemon. We can have a Blastoise card component file for the Blastoise Pokemon, the Venusaur card component file for the Venusaur Pokemon, etc., etc. But the thing is, when we run our application, we're only going to see details of the Charizard card component. If we want to enable routing, what we essentially need to do is have the parent app components dictate which Pokemon components display when the application gets loaded for the very first time. That's essentially what we need to happen. And notice how we're using components as the blocks that get changed or re-rendered. This is because components are really good, useful, coupled units of functionality. All right, so we have an idea of the game plan, and we have our presentational components prepared. Let's go about actually building the router. We'll build all the router files within a single router folder, and we'll have 3 files in total: a router link.vue file, a router view.vue file, and a routes.js file. As we can see, router link and router view are components, while routes.js is just a simple JavaScript file. If we take a look at the routes.js file, we'll see that it has a single responsibility. Its responsibility is to simply map the components to the path names in which they should be shown. So in the beginning, we'll import all the components that we want the router to take care of. And at the bottom, we'll export an array that contains a series of objects. Each object will contain a path key and a component key. And what we're basically clarifying here is we want this components or these components to be shown for these paths. So we basically want the Charizard card component to be shown in the index path. We also want that same component to be shown in the Charizard path. We want the Blastoise card and Venusaur card components to be shown in the Blastoise and Venusaur paths respectively. Now, when we specify the path here, we're referring to the path name of the URL. If we recall, the path name is simply the indicator to a particular resource on our web app. What are these resources? These are the components that we're referencing here. OK, so the routes.js file simply does the mapping for us, but it doesn't actually do any of the work. That will be the responsibility of a router view component that we'll create. Now, router view will be a component that's responsible in rendering another component based on the app's location. And it'll do so by being the mounting point for Vue dynamic components. There's a lot happening here, so we'll break it down step by step. So Vue dynamic components is an ability in Vue to allow us to basically dynamically switch between components based on a data attribute. And we can do so by using the reserved component keyword. So at the very top, we're using the reserved component keyword and binding an is attributes to the current Vue data property. If you look at our data function, we can see right now that our current Vue data property is an empty object. So this won't do anything. But if, for example, if we imported the Charizard card components and declared it here, our dynamic component will render Charizard card. But that's not dynamic, that's static. We need to dynamically determine what the current Vue data property is going to be. How will we do that? We'll first take into account the routes array. The routes array has all the mapping for us. Oh, sorry. Oops. And we'll create a method to help us as well. We'll label this method called getRouteObject. And this method's responsibility is to basically filter through the routes array and pick the route object in which the route path is equal to the window location path name. Window.location is a special object that contains details of the current browser's actual location. And we're simply grabbing the path name, which is part of the URL that we want to survey. So this method simply returns the object in which the actual route path is equal to the window location path name. Now, with this method prepared, when do we actually want to run it? We want to run this method when the actual application gets created for the very first time. So if we're using the router view components, we want this to run when the router view component gets created for the very first time. So to make this happen, we'll use the created lifecycle hook. Created is one of the many lifecycle hooks of a Vue component as well as a Vue instance. There's created, updated, mounted, destroyed. They basically get run through the lifecycle of a component. This particular hook gets run when the component gets created for the very first time. So what we're saying here is when the router view component will get created, we want to check if the getRouteObject method returns undefined or nothing actually gets returned. If it does, we'll bind the current Vue data property we have in this component to a simple template that contains a header element. This header element will say, I'm sorry, we couldn't actually find that Pokemon. This is our way of doing a very simple 404 or a not found page if the user attempts to access a route that we haven't defined. But if the getRouteObject method actually returns something, we'll bind the current Vue data property to the component property of the object that's being returned. Awesome. So this should work. So now in our parent app components, we shouldn't be importing Charizard card anymore. We should import the dynamic router view component declared in a component's property for us to use and render it in the template. Now when we run our application, depending on the route that we go to, we'll see the correct component. It was easy as that. And if we go to a route that we haven't defined, maybe /Pikachu or something, our application will tell us, I'm sorry, we couldn't find that Pokemon. So we're already more than halfway to where we actually want to set up a router. The other thing we want is we don't want the user to use the URL bar to navigate from Pokemon to Pokemon. That's not intuitive. We'll provide them links like most web applications. We can have these links at the bottom of the actual app. Now, our first instinct is, why don't we use a simple anchor element to navigate to a particular route? The issue is, an anchor element actually tells the browser to make a web request. We don't want to make any requests at all. We want our application to be a single-page app. We want the browser URL to change, and we want the router view component to be responsible in determining which Pokemon to show. So we're going to have to create a special link component of our own. And we can call this router link, and we can create this within a routerlink.vue file. The template of router link will contain an anchor element, but there's some special things attached to it. The first thing is a click event listener denoted by the @click syntax. And what it says is, when we click the anchor element, it's going to call a navigate method. In addition, we're going to bind the href attribute of the anchor element to a toData value. We're also going to use a mustache syntax to bind the toData value into the text content of the anchor element. We'll see what that value is shortly. In the script section, we'll export the components and give the name of router link. And then we're declaring a props attribute. So props is a way of passing data from parent components down to child components. Here, we're specifying a prop called to. So we're saying when we render the router link components, we expect to pass this prop downwards from the parent. We're also specifying some prop validation requirements. So now either of these aren't met if it's not a string or if it's actually not been used at all. The Vue console will emit warnings. And finally, in the method section, we'll have the navigate method. Now, if you recall, all click event handlers have access to the event object as the very first argument. So the first thing we're going to do in our navigate method is call the prevent default method on the event object. This will tell the browser to actually skip the default routine of making a web request. And the second thing we're going to do is we're going to call a push state method on the window.history object. Window.history is a special object that contains the browser's history. Of immediate interest to us is the push state method, which pushes a new location into the browser's history stack. The push state method takes 3 arguments: a state object to pass serialized state information, the title, and the target's URL. We'll assume we don't need to pass any state information, and we don't actually need to specify title. So we're going to specify null as the first 2 arguments. But what's important is we're going to pass the value of the toProp as the third argument. So this toProp should be the target URL that the user wants to navigate to. So now this target URL could be the absolute URL path, but in our case, it would be the relative path name. And if we pass the path name alone, it will get resolved relative to where the user is. So if we're developing locally and we pass in /Blastoise, the push state method will actually push a new location of localhost 8080/Blastoise. Perfect. And notice how we're still binding the href attribute at the very top. If you think about it, we're actually preventing the anchor's element of ability of actually making a web request. So we don't need to define it at all, but we're going to keep it because it actually allows us to now hover over a link, and it tells us where it navigates to, which is super useful. Perfect. So at this very moment, if we use the router link element and if a user actually clicked it, the browser location will change. The URL will be updated. But the issue is the router view components will be unaware of the change. This is because router view only picks the correct Pokemon component when it gets created for the very first time. We need to now have router view be notified that a user is attempting to change the location. There's a few ways we can do this. One way is to basically spy on the route, etc. But an easier way is basically have the router link components emit a custom event to router view. So custom events is a useful way in Vue components to usually pass information from child components up to parent components. But since router link and router view are completely isolated and they're pretty much sibling components, we're going to have to use a special form of custom event. We'll call this an event bus. So an event bus is essentially a Vue instance that's used to enable isolated components to subscribe and publish custom events between each other. So an event bus is just a new Vue instance. Vue components are Vue instances. Every single Vue instance has their own custom events interface. An event bus is just a Vue instance in which its custom events interface is allowing isolated components to subscribe and publish custom events between each other. How does it do that? It's made global for this purpose. You can attach it to the window object, or you can create an instance of it somewhere. So we'll create an event bus.js file where we import the Vue library and we export the Vue instance. So now with the event bus available, in our router link components, we'll import the event bus, and at the end of the navigate method, use the event bus events interface to emit a custom event. We'll give the custom event a name of navigate. But this is only one half of our event communication. Now in our router view components, we need to declare the event bus listener. we'll declare the listener in the created lifecycle hook of the component. And what that basically says is when router view gets created, we're attaching the event listener to a callback function. So now throughout the life of this component, whenever this event gets ever fired, that function will actually fire. Now, what is that function? That function gets run, and it says it's going to bind the current view data property to the component property of the route object that gets returned. So once again, we're just simply running the getRouteObject method we've created. That object will now pick a new route object because the window location has been updated, and we're going to get a new component. Fantastic. Only thing left for us to do is import the router link elements, declare it in the components property in the parent app components, and finally render it in the template. Notice as we're rendering it in the template, we're specifying the toProp that it expects, basically the path names that we want the link to navigate to. If we recall, we're also using the toProp to be bound to the text content of the anchor element. So in our application, we'll actually see those values below, /Charizard, /Blastoise, and /Venusaur. And now when a user clicks any of these links, the URL will change, and the router view component will be notified of the change, and it'll pick the correct Pokemon component. Beautiful. We're almost there. There's only one last thing to consider. The router view component only picks the correct Pokemon component when it gets created and when we click a router link element. We haven't done anything for browser navigation events. Now, when we click browser back or browser forward, our URL will change, but the router view component will be unaware of that change. So to make this work, we'll use something known as the pop state event. Pop state is an event of the window object that gets triggered when a direct browser action is made. Now keep in mind, pop state does not get triggered when we use the history.pushState method. It gets triggered when we have a browser action like browser back or browser forward. So what we'll do to help resolve this is, let's say in the parent app component, specify the event bus, we'll import it, and in the created lifecycle hook, attach an event listener to the window object. And we'll say when the pop state event ever gets triggered throughout the life of the components, we'll use the event bus to emit the same custom event called navigate. Router view is listening to that custom event, so it'll be aware of the change, and it'll pick the new Pokemon component. And now our browser works when you go browser back and browser forward. And that is essentially what we needed to do to actually build a fully functional custom client-side router with Vue alone. So there's three things we introduced. So if, for example, we're going to make this a library of sorts, and we're like, hey, people install it and use it, we'll tell them to define three things to follow a certain pattern. We'll say, declare your routes array that's responsible in mapping components to the respective URL path names. We want you to declare the router view component that's responsible in rendering another component based on the app's location. And we want you to declare a router link element that allows the user to change the location of the browser without making a web request. Now, these three pieces are actually the main core pieces of the Vue router library. We've just built a custom client-side router to mimic how Vue router works. So with that said, we're going to take a look into how Vue router can actually be integrated instead of our custom router. So first, from the Vue router documentation, it says Vue router is the official router of Vue. It deeply integrates with Vue to make building single-page applications a breeze. And it really is that easy. So Vue router is a library, so it needs to be introduced. NPM, Yarn, a content delivery network. And for module-based apps, Vue router has to be explicitly installed. You can do so by specifying Vue.useVueRouter, where Vue is an import of the Vue library, and Vue router is an import of the Vue router library. So now when it comes to our application scaffold, we don't need all the custom files we've created. We'll instantiate or create our entire router within a single router.js file, for example. So in the beginning of router.js, we'll import Vue, Vue router, and we'll import all the components that we want our router to take care of. We'll specify Vue use Vue router because our application is a module-based web app. And finally, we'll then create the routes array like we've done before. The routes array simply maps components to the respective path names. The only thing that's new here is a new route object in which the path value is given a star symbol. This is Vue router's way of us specifying a not found page or 404 error if the user attempts to access a route that we haven't defined. And at the end, we'll simply export the Vue router instance. So the Vue router instance can be created by specifying new Vue router and passing in the options that make up the instance. At the very minimum, the Vue router instance expects the routes array, which is basically the array that maps the components to the respective path names. But we're also passing in another property. We're passing in a property called mode, and we're specifying a string value of history. What does that mean? So Vue router's default mode is hash-based. That basically says when you immediately use Vue router, your URLs will be in hash mode. And that entails that after the domain name or the host name, you're always going to be presented with the hash symbol. Now, why is this here? I'm sure some of us have seen this. Now, the benefit to this is usually allowing us to have multiple client-side routes without having us to provide the necessary server-side fallbacks. What does that mean? So everything after the hash symbol in these kind of URLs are never sent to the server. So if our application was a server-rendered app, we're basically saying that everything before the hash will be sent to the server will return an index, and then everything after the hash will use ViewRouter to dictate which components should be shown, which is super useful. But the thing is, the application we're building is a single-page app. The server is going to return the same index regardless of what URL we use, so we don't need the hash mode URL. Instead, we'll make our URLs history mode, and these are more familiar with what we've just seen. There's no hash symbol, and we simply have the domain name followed by the path name. Okay, finally, if we want to be able to use the components that ViewRouter provides, we need to import the router instance and declare it within our global Vue instance. And now, in our parent app components, we can use the router view component and the router link component like we've done before. Router view simply declares another component based on the app's location, and router link allows us to change the location without making a web request. The only difference we've done here is we basically specify text content within our router link elements. And ViewRouter gives us more flexibility to actually define what these elements should display. Now, our application would work just like we had before. We go to any of these routes, we'll see the correct Pokemon, and if we attempt to access a route that we haven't defined, let's say /Gyarados, our application will tell us, I'm sorry, we couldn't find that Pokemon. Beautiful. Notice how easy that was? So there's one important note I want to make. So even though our custom router mimicked how ViewRouter works, it wasn't built anything along the same way. ViewRouter is a lot more well-tested and a lot more robust. In addition, ViewRouter ensures consistency between a much larger different number of browsers. And I think, if I'm not mistaken, goes all the way back to IE8. I didn't test that custom router on IE, but I think it works. In addition, even though ViewRouter was very simple, it allows us to scale things up as our application starts to grow. It does so by allowing some really fine navigation control, things like dynamic route matching, nested routes, and navigation guards. I consider these things really useful, so I'm going to spend a little bit of time talking about what they are. So the first thing we'll talk about is dynamic route matching. So if you notice, in our application, we basically create a component file for every single Pokemon we wanted to show. And it was fine, because we only had 3 Pokemon. But if we wanted to build a database or basically an app that shows details of every single Pokemon that existed, we're going to have to create hundreds and hundreds of component files. That's unreliable and that's not sustainable. And if you think about it, each of these component files have the exact same template and pattern. The only difference between them is the data that's being displayed. So with dynamic route matching in Vue, we can basically use dynamic routes to map routes of the same pattern to a single component. And we can call this component something along the lines of Pokemon card. So how would we actually go about doing this? So the index route was unique, but every other route we defined followed a particular pattern. The path was a /Pokemon ID, and the component was a particular Pokemon card. So we can group all those similar paths and similar route objects to a single route object. This route object will be unique and dynamic because the path will have a dynamic parameter. Here, the path says /Pokemon/:ID. The ID part here is the dynamic part of the URL in which we can satisfy it with anything. So if we say /Pokemon/Charizard, /Pokemon/Blastoise, etc., they'll all get resolved to this path and all get mapped to the Pokemon card components. Now, why is this useful? Because in the Pokemon card components, if we place the console log somewhere, we can actually access that ID param. We can access it with this.route, which gives us the actual route, and the params object of it, which is the actual parameters of that route. So if we access the route that said /Pokemon/Charizard, this console log message will give us Charizard. And now there's many things we can do now, right? We can use this parameter to make an asynchronous call, etc. But one thing we can also do is, let's assume we had a data array on our client side, and this data contained all the objects we needed in our application. And every single object involved data about a particular Pokemon. This isn't probably the most ideal way of doing things, but we can filter the array and find the object in which the ID matches the URL parameter ID. So now with our object available in our Pokemon card components, we can keep this object within a data function. And now we can bind that data function, or that data object into the template with the help of the vbind directive and the mustache syntax. So this makes Pokemon card an entirely dynamic component. There's no more static information. And if we wanted to make more and more Pokemon get into our application, all we essentially need to do is just create new objects in the array. We don't need to create any more routes. We don't need to create any more components. Our dynamic routes will take care of everything. The second thing we'll talk about is nested routes. So most web applications we use usually have components nested multiple levels deep. So in our application, we only had a parent app component and a Pokemon card component. So now what if our Pokemon card component was going to be a parent of its own and it was going to render a Pokemon stats component? There's nothing wrong with this, but if we wanted Pokemon stats to actually dynamically render based on the route that the user is in, we'll need to use nested routes. Nested routes constitute having a parent route followed by multiple different nested routes. So we know the /Pokemon/ID route gives us the Pokemon card component. But we can add something to the route to say if we added stats to it, it'll give us the Pokemon stats component as a child. But if we specified Pokemon ID evolutions, it'll give us the Pokemon evolutions component or any other components we have in mind. So you can see how useful this is. There's two things we need to do to make this happen. The first thing is basically declare a children property or a children array within the route objects. This children array will contain the same series of objects, with each object having a path key and a component key. But in this case, the path gets resolved relative to the parent path. And the components here are the nested child components that get rendered in the parent component. The second thing we have to do is actually declare the router view components in the parent component that actually needs it. So we had the router view component in the parent app component, but in this case, we have router view in the Pokemon card component as well. And finally, the last thing we'll talk about very briefly is navigation guards. So navigation guard is an ability to allow us to guard navigations by either redirecting it or canceling it. And it's really useful if you want to basically verify some form of parameter authentication before allowing the user to actually navigate to certain protected routes. In Vue Router, there's three types of navigation guards: global navigation guards, per route navigation guards, and in-component navigation guards. Global navigation guards involve specifying a guard for every single route in our router. And to do so, we'll simply specify a before each function on the router instance. Now, global navigation guards, as well as all navigation guards, have access to three arguments: the target route object, from which we can get the path, the current route object, from which we can get the path of that as well, and the next function. The next function is the function that must be invoked to complete the routing process. Simply declaring next completes the routing process and takes the user to the route they intended to go. Declaring next and specifying an argument of the path name actually redirects the user or forces the user to go to that particular path. And finally, declaring next with a false Boolean simply cancels the navigation outright, and the user remains where they are. Similar to how we have a before each function, there also exists an after each function, which is basically a method that gets run after the routes are complete. These aren't navigation guards because the route's already complete at this moment. In this case, you only have access to the target route object and the current route object. Per route navigation guards work very similar to global navigation guards, but in this case, we only specify the guard for particular routes. So here we're saying a before enter property, which will only specify a guard for this particular route in our application. And finally, there's in-component navigation guards. Now, why do we use in-component navigation guards as opposed to per route navigation guards? This is because if we had multiple routes that actually routed to a single component, we can guard all of these routes by keeping it within a particular in-component navigation guard. There are three types of in-component navigation guards. Before route enter, this is when a route that's about to be rendered for a particular component is about to happen. Before route update, this is when a route's about to be updated, but the same component is about to be re-rendered, useful for dynamic routes and having a single component. And before route leave, this is when a route that's about to be navigated away from a component. Similarly, you have access to the same three arguments, the target and the current route objects, as well as the next function. So you can see how much more useful Vue Router is if you wanted to actually build appropriate routing for a medium to large scale application. And it offers even more things like programmatic navigation, redirects, aliases, transitions, and lazy loading. Now, lazy loading is an incredibly cool feature in which Vue Router works with Vue's async components and Webpack's code splitting to allow us to actually split our application to separate bundles. Now, I didn't want to talk only a little bit about it because I think it's super important, and I think a whole talk could be dedicated to it. But essentially, with lazy loading, we can actually separate our Vue components in such a way that the components will get rendered as separate bundles. And if you remember in the beginning of the presentation, I specified that one of the issues with client-side routing is the client has to make a request to the entire application bundle. This actually avoids that. We can actually load separate small bundles over time, which really saves performance. That's sort of what I wanted to present today. I hope it was useful in either displaying what client-side routing is, how we can go build it, as well as Vue in general. If you are interested in how Vue Router works, I'll urge you to go to the Vue Router documentation. It has a lot of useful features and it's really well written. If you're interested in the exact same example I built today, a Pokemon routing application with custom functionality, I've written an article called "Let's Build a Custom Vue Router" that literally goes almost through what I've just talked about today. Before I close, there's two quick things I want to talk about. So I work primarily at Shopify. If any of you is interested in what I do at Shopify, you're more than welcome to reach out to me. I'm part of the app and partner platform team, so I help build the UI in which other partners and developers actually work on. I don't use Vue in Shopify. I use React and primarily a little bit of Rails. I do Vue everything outside of my day job. And the second thing I wanted to talk about, which I mentioned briefly in the beginning, if anyone's interested in a learning resource for Vue, you're more than welcome to check out my book called Full Stack Vue. You can reach out to me if you have any questions, thoughts, opinions, and you can find all the details on the website, fullstack.io/Vue. And that's pretty much what I had in mind. This is my first time giving this particular presentation, so I really urge you guys to give me any feedback you have whatsoever. I'm going to be here today, tomorrow, so do let me know how I did. That's my Twitter handle. I'm trying to be a lot more active on Twitter, so holler at me there. I don't use LinkedIn too often, but you can also find me there as well. Thank you, everyone. Appreciate it.